Welcome to The Explainer. Today, we're breaking down the incredible strategy behind our best weapon against malaria, and, maybe more importantly, the constant battle to make sure it stays effective.
So how do you fight an enemy that's always evolving, always one step ahead? That's the core problem when you're up against one of our oldest enemies, the malaria parasite. This thing is a microscopic master of survival, and for a long time, it was absolutely winning the fight.
You know, for decades, it felt like we were in this desperate race, a race we were losing. First, the parasite learned how to shrug off chloroquine. Then, it outsmarted the next wave of drugs we threw at it. By the time we hit the 2000s, our best weapons were failing. The global health community was facing a full-blown crisis, and we needed a new game plan, like yesterday.
And the solution, when it finally came, wasn't from some high-tech lab or a brand new synthetic molecule. Nope, it was actually a rediscovery. A secret weapon, you could say, that had been hiding in plain sight for centuries, used in traditional Chinese medicine to treat fevers.
So this natural compound is called artemisinin, and it was incredibly powerful. But here's the catch. Just using it by itself wasn't going to be enough. To really, truly outsmart this parasite, scientists realized they had to build an entirely new strategy around it.
Okay, so let's get into how this actually works. The strategy is called Artemisinin-based combination therapy, or ACT for short. And the key word there is combination. This isn't just one drug, it's a team, a powerful team designed to launch a really strategic attack on the parasite.
The best way to think about it is like a 1-2 punch. First up, you've got the artemisinin part, which we can call the rapid killer. It's basically a shotgun blast of destructive particles that just overwhelms the parasite. It hits incredibly fast, but it's also out of your system really quickly. And that's where the cleanup crew comes in. This is the partner drug. It's slower, but it's long-lasting. And it uses a completely different attack plan to hunt down and wipe out any parasites that manage to survive the first hit.
And when we say that first punch is powerful, we are not kidding. We're talking about a 10,000 times reduction in the number of parasites in the blood. And that happens within hours. It's just staggering. This is what gives patients that almost immediate relief and basically stops the disease dead in its tracks.
Okay, so here's where it gets really, really clever. The crucial point isn't just that these two drugs work together to cure someone. The real genius is how they actually protect each other from the parasite's #1 trick, developing resistance.
So here's how this double lock defense actually works. First, you have the Artemisinin Blitz. It is so powerful, so effective, that it wipes out more than 99.9% of the parasites. Now, what about the few that are left? Well, any survivor that might have a tiny bit of tolerance to that first drug is immediately hit by the second wave, the partner drug. And that partner drug attacks it in a totally different way, a way it's just not ready for. It really is like needing two separate keys to open one lock at the exact same time.
And that right there, that double lock mechanism, is the absolute genius of the ACT strategy. It's why they've worked so well for so long. I mean, think about it. The odds of one single parasite randomly developing two completely different life-saving mutations at the exact same instant, well, they're just astronomically low.
And hey, the results, they really do speak for themselves. This strategy has consistently given us cure rates of over 95%. That's just a remarkable success story. One that has saved literally millions of lives all over the world.
But, and there's always a but in this story, we have to remember what we're up against. This is a race against evolution, and the enemy never, ever stops adapting. So the incredible success of ACTs, it's not guaranteed to last forever.
So today, it's not just one type of ACT. There are actually several different combinations used all around the world. And the one a doctor chooses really depends on what's happening locally, what the resistance patterns look like in that specific area. Each combo has its own quirks, right? From unique features to how you're supposed to take it, to the kinds of side effects you might see.
Which of course leads to the big question. What happens when the parasite finally starts to pick that lock? And this is where we get to the sobering reality of the challenges ACTs are facing right now. That extremely unlikely event we mentioned earlier, well, it's starting to look a lot less unlikely. It's moving from a distant threat to a very real, emerging crisis.
And the threats are coming from all sides, really. On the biological front, we're seeing the very first, very worrying signs of artemisinin resistance. But it's not just biology. There are criminal threats too, like the flood of counterfeit drugs on the market that don't work and actually make resistance spread faster. And then there's the simple, tragic barrier of just getting these life-saving drugs to the people who need them most because of cost and access issues.
And that nightmare scenario is already starting to play out, especially in Southeast Asia. We're seeing parasites that are, well, they're tougher. They aren't killed off as quickly by the artemisinin. They're lingering in the body for longer. Now, this doesn't mean total treatment failure, not yet. But what it does do is put a massive amount of pressure on that partner drug to do all the heavy lifting, and that dramatically increases the chances that the parasite will figure out how to beat that drug next.
So it all comes down to this really critical question, doesn't it? The double lock strategy was an absolute masterstroke, but is the parasite already picking that first lock? ACTs were a brilliant strategy that bought humanity so much precious time, but the parasite is just relentless. And it's a stark reminder that in this race against malaria, the finish line is always, always moving.